Hi guys, this video is running through the content for summing matrices and application of product matrices. So firstly, a summing matrix is a special type of row or column, and we use this by either pre-multiplying or post-multiplying another matrix so that we can add up the rows or the columns. So, for example, if I have a matrix, let's just look at this matrix A that we've got on the page. And let's say I did want to add up the rows of that matrix. So I wanted to be able to perform a function where I am adding 1 plus 2 plus 5 and getting a result, and 6 plus 3 plus 10 and getting a result. So when I'm adding rows, I'm using what we call post-multiplying. And the size of that column matrix has to be an n times 1. So it's going to be a single column, and the number of rows it has is equal to the number of columns in the original. So first here we're going to note down A is a 2 by 3 matrix. And so when I want to do that adding of the rows, that means I'm post-multiplying, so after the matrix, by my 1 by 3 summing matrix. So if we look at what impact that actually has, my answer will be here a 2 by 1, okay, because I'm going to have a calculation which is just the sum of the first row and sum of the second row, so two numbers in the end. So using my run and dive method, I'm working across the top row down the column. So I've got the numbers 1 times 1 plus 2 times 1 plus 5 times 1. And so you can see there, I'm actually just multiplying each of those values in the row by 1. So when I complete that calculation, I've got 1 plus 2 plus 5, 8. When I move on to the second row, so row 2, column 1, to get the value in that position in my answer, 6 times 1, 3 times 1, and 10 times 1. So again, when I complete that calculation, I get the value 19. Now, you might say, but I could just add those numbers up. And yeah, you could. However, if a question specifically asks you to use a summing matrix or to identify a possible calculation from a set of multiple choice answers, you need to know what it could look like, okay? Similarly, if I want to add the columns, then instead of post-multiplying, I am going to pre-multiply. So when I'm doing columns, I pre-multiply by a row matrix. The number of columns in that row matrix, to make it defined, has to be the same number as the rows in the second matrix. Okay, so again, what does this look like if we multiply it out? Working across our row and down our first column, so 1 times 1 plus 1 times 6. Then in the second position, so row 1, column 2, I've got 1 times 2 plus 1 times 3. Row 1, column 3, I've got 1 times 5 and 1 times 10. And so when I then complete those calculations, I end up with 7, 5, and 15. So again, you could easily just add 1 and 6 gives me 7, 2 and 3 gives me 5, so on. But again, it's about knowing this is what it can look like and understanding in particular this language, post-multiply, pre-multiply. The reasoning for the sizes there. So making sure you've got that clear. Okay, so some examples for us. We have here Kai has a part-time job, and each week he earns money and saves some of this money. The matrix below shows the amount earned and saved in dollars for each of the 3 weeks. Using the summing matrix, or using a summing matrix, find the total amount earned and saved by Kai over the 3 weeks. So we want to use a summing matrix and we want to find the total that he has earned and saved. So we actually want the total of the earned column, the total of the saved column. So that means I want to add the columns. So I'm going to need to pre-multiply. Okay, so I'm going to pre-multiply by a row matrix. I have 1, 2, 3 rows. And just filling in that matrix. And then when I do this calculation, 1 times 300 plus 1 times 270 plus 1 times 240, I end up with 810. In the first row, second column, 1 times 100, 1 times 90, 1 times 80, I end up with 270. And there is my 2 totals. So therefore, he earned 810, saved 270. Our labels still carry forward. Okay, so if we wanted to put that as our labels, we could. And that's now giving the total of the 3 weeks. Okay, our next example here is an old past exam question. And to give you an idea of how you might have to recognize how these summing matrices can be used. So here we have a school has 3 computer classes, class A, B, and class C. And there are 15 students in each class. Each student has been given a mark out of 100 based on their performance on a test. And so the matrix M below shows the marks obtained by the 45 students listed by class. So we can see our row headings here are the classes of the students. 2 other matrices, S and R, are defined below. And you can see we've got 2 summing matrices because they're just either row or column, and they only contain the numbers 1. So they represent a summing matrix. Which of the following matrix expressions can be used to generate a matrix that displays the mean mark obtained for each class? So we want to stop and think about what do we want to end up with. If we want the mean mark for each class, then we want to end up with 3 values. So our result either has to be a 1 by 3 or a 3 by 1 matrix. Okay, so we end up with 3 numbers in total. An average for class A, an average for class B, an average for class C. If you were going to find the average of those classes, there are 15 students in each one. So if I said to you, tell me the average mark for class A, what you would do is add up the values for class A. So you would add up the row. You would then, I'll just make a note, add the row. You would then divide that by the number of students, so by 15. And that would give you your average. So if we think about how can we use matrices to do that, if I have to add the rows, okay, then that means if I go back to the previous page, I have to post multiply by a column matrix. And so here, S is my column matrix I can use. So we already know we're going to do a post multiplication by S. I also need to divide by 15. And so that's where I can use a scalar multiplier. Okay, so if I have to divide by 15, I can't write that as a division with matrices. I always have to multiply, but I can do that as a 1 over 15. If I divide by 10, I'd do 1 over 10. If I had to divide by 2, I'd do 1 over 2. So it's always 1 over whatever you want to divide by. So here is what I think is going to be my best answer. So let's see out of the options if that is there or if there's something slightly different but similar. So A, 1 over 45 times m. No, that's just going to divide all of the numbers and leave me with 45 different values. 1/3 over times r times m, that will give me the sum of the columns, not the rows. So that's not going to help. If I skip down, I can actually see, yes, I have my answer here. Okay, but it's about knowing why we can't do these other ones as well. So we would end up with things that are not the size that we want at the end, particularly with C and E. They would give us things that don't give us at the end the amount of values that we want. Okay, so not often that it does come up, but when you see a summing matrix or in actual matrix form or referred to in words, it's about knowing what its use can be. And that's where you always want to come back to this section to remind yourself what must it look like. Might even be a good idea to put yourself here next to the little definitions, a picture of what that looks like. Okay. Obviously you also have that glossary at the back as well. And so there are examples of summing matrices, okay, on that page 47, but it might not be as clear as you need it to be. All right. That should get you through the remainder of exercise 7D and through the lesson today. Thanks.